All right, so in this one we're going to look at a problem that's a little bit more difficult. It again requires us to use the general term for a binomial expansion. There are ways to do this without the equation. It just takes your understanding of binomial expansions and you just have to write it out. And I'll show that to you after I use the general term, just so that you're aware, just so that you can do it even without the general term if necessary. Okay? So if we can avoid the kiloworms, we will go ahead and consider x squared plus 4 over x to the 12th power. We want to find the x to the 6th term and also the constant term. So we're looking for two different terms here. Constant term, remember, constant just means that there's no variable, which means that we want x to be to the 0 power. Okay, it's not necessarily the last term, because the last term here is going to be 4 over x to the 12th. Which would be 4 to the 12th over x to the 12th. That's not a constant. So we need something in between what this first term would be, x to the 24th, and this last term, which would be x to the negative 12th. Somewhere in the middle, we're going to have an x to the 6th, and we're going to have an x to the 0. Okay, so first I'm going to show you how to do this using our equation. So we've got tr plus 1, which equals in r, and then a to the n minus r and b to the r, just like that. That's what we were using in the previous video, so let's go ahead and work through that. So if we want the x to the 6th term, then 6 is, that's what we want the variable end up as. We don't know what r plus 1 is, we don't know what r is, we do know what n is, because that's our power here. So let's go ahead and write, we want t r plus 1, which we don't know what that is, equals to 12 over r. Now a, of course, is x squared to the 12 minus r power, and then b, which is 4 over x, is to the r power, which we don't know what that is. Okay, now I'm going to actually take the liberty here of rewriting the 4 over x, and I'm going to rewrite it as 4x to the negative 1. Just because it'll make the math a little bit later, a little bit easier later. It doesn't matter, it's okay. If you want to leave it over x, that's fine. You can work it out that way as well. Okay, so from this point, I'm looking for the x to the 6th term. Now, I don't know yet what the coefficient is to that. So really, that's what I want in the end. The problem is I can't get that coefficient unless I know to what power I'm raising this, and what power I'm raising that, and what the r is here. So I can't go do it right away. So my first priority needs to be to find r. Now, the only information I have right now is that I need x to the 6th power. So what I'm going to do is I'm going to look at this, and I'm going to determine what needs to happen such that I can get x to the 6th power. Well, you know, the first thing I do is I look at this and I see 12r. That's just a constant, right? That's just a coefficient. That is not going to affect the power of the x. And so just for a minute, I'm going to ignore that. It's not helpful right now. The same thing with the 4 right here, right? That r is going to distribute to the x to the negative 1. It's also going to distribute to the 4, but it doesn't really matter what 4 to the r power is. That's not going to affect the x to the 6th. So I'm going to take that one out just for a minute. Okay? So now I've got it down to just the variable part of my term. And so I need x to the 6th to be equal to x squared to the 12 minus r and x to the negative 1 to the r. And so from there we'll go ahead and simplify. So power over power we multiply. So x to the 24 minus 2r and x to the negative r. Now you may be able to skip some of these intermediate steps. I'm going to go ahead and show it all so that you don't look at them and look at me and be like, what? So there we go. We'll go ahead. When you multiply, you add the exponents. So we're going to have x to the 24th minus 3r. If you want to do this like formally, then we take the log base x, and that will cancel out the x. Or you can just say, what the heck, I've got the same base here. That means that 6 has to equal 24 minus 3r. If 24 minus 3r isn't 6, then those two things can't be equal. So from there we solve, we subtract the 24, divide by the negative 3, and we end up getting that 6 equals r, because that would give us negative 18 divided by negative 3, which is 6. So we've got r now. That's not the end, because that just told us that we're using the 6th element. With that, we can now put it back into our original equation right here, and we can solve. So we're going to go up here, and we're going to go t 7, which is the 7th term, right? Because r is 6, so 6 plus 1 is 7, equals 12, 6, x squared to the 12 minus 6, which is 6, and then 4x to the negative 1, also to the 6, because r is 6. All right, so we can go ahead and work it out. Really, right now, you don't need the x squared and you don't need the x to the negative first, because all we really care about is the coefficient. But what I'm going to do is I'm going to go ahead and leave it there, because I just want to make sure that this is really the x to the 6th term. So now I got 12, 6. I'm going to go 12 NCR 6, which is 924. So 9, 2, 4. This will give me x to the 12th. Then I need 4 to the 6th power there, which I seem to remember doing that. But 4096. So times 4096 x to the negative 6. We put all that together. I'm going to take 924 and multiply it by 496. And I get 378. So again, 3 digits is fine. So I'm going to just write out that T7 equals 3.78. So that would be 1, 2, 3, 4, 5, 6. E to the 6, so times 10 to the 6th. X to the 12th and x to the negative 6 end up giving me x to the 6th. All right, so there you go. You found the term of the x to the 6th. Well, you found the whole value of the x to the 6th term, I suppose. All right, so there we go. That's the first part. We've avoided the killer worms so far. So now we want to continue to avoid those killer worms as we go on to the constant term. So this is going to be exactly the same, except this time we're looking for the constant term, which is x to the 0. So if you want, go ahead and pause it, work through it yourself, and then I'll show you how to do it right now. Okay, so hopefully you paused it, you worked it through. Let's just check your work. So this time, again, we can get rid of, we're dealing with the same thing here. We're going to ignore the 12r, we're going to ignore the 4. So again, we're down to, we want x to the 0 power to be equal to x squared, 12 minus r, and then x to the negative 1 to the r. And so we want x to the 0 to be equal to, now you obviously don't need to do this because this is all going to be exactly the same. You're just going to end up with 0 equals 24 minus 3r. But just in case you don't believe me, because I know that just happens, sometimes people don't believe me. It's unbelievable because how could you not believe me? You probably don't believe me that there are killer worms, but there are. Watch out for them. So then we go 0 equals 24 minus 3r. Then we solve, we add the 3r or subtract the 24, it doesn't matter, and you get r equals 8. So now we've got r equals 8. We go ahead and plug it back into the original. So t, remember this is r plus 1, so t9. So the 9th term equals 12, 8, x squared to the 12 minus 8, which is 4, and then 4x to the negative 1 to the 8th power. We work that out, and we get killer worms. Oh no, they're here. They're going to eat our math problem. Oh no, wait, they're not. We're just going to delete them. What? Delete. Oh no, I deleted half of my problem too. That's life. So we already got that. Okay, let's go back. This for our final answer. So 3.24 e to the 7th or 324,40320. That's the exact value. And that is the constant because the variables canceled out. All right, so I hope that was helpful. If you want to see one that's just a slight bit harder, then go ahead and look at the last video. Ciao.